Hello class, welcome to another video. So this video is a continuation of the previous video, and we are going to be uh, checking on some more problems which are based on interpolation. So in the previous video we have only dealt with problems where we have to use Newton's forward interpolation. Now let us see some problems where we have to use Newton's backward interpolation as well as Lagrange's interpolation formula. Okay, so let us consider this problem. Okay, suppose you have the marks. Suppose you have the marks and you have the number of students. Okay, and the marks are given in intervals from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay, and the corresponding number of students, okay, those who scored between 0 to 10 are 15, then 10 to 20 will be 12, then 10, then 8 and 5. Okay, so this problem you have to find the number of students who secured less than you have to find the number of students who secured less than 45 marks. Okay, so you have to find the number of students who secured less than 45 marks. So we see that 45, it lies in this interval 40 to 50, and this is towards the ending of the series, and thus you know that you have to use Newton's backward interpolation formula. Okay, and so this type of problem where you are given in class intervals, you have to find the cumulative frequency table. Okay, so let us first construct the cumulative frequency table. So you have your x values, marks, you have your x values where they are the marks which are less than x, and then you have the number of students where you denote by fx. Okay, so you take only the upper limits 10, 10, 20, 30, 40, 50. Okay, you take only the upper limits of those intervals. Okay, so the corresponding cumulative frequency. So the first cumulative frequency will be the first frequency only 15. Then the next will be 15 plus the next frequency 12, which is equal to 27. Then the next will be 27 plus 10, which is equal to 37. Then next 37 plus 8, which is equal to 45, and the last 45 plus 5, which is equal to 50. Okay, and when you add the frequency which is given in the question, you should get the total of the frequency to be 50. Okay, so we have constructed the cumulative frequency table. Now you have to write down the formula which you have to use. Okay, so you have to write down the formula which you have to use, and here how many values of x you have? You have 5 values of x, so you have to write down the formula till delta 5 minus 1, which is equal to delta 4. Okay, you have to write down the formula till delta 4. So let us write down Newton's backward interpolation formula. So it is given by y equal to fx equal to okay, so the last it will start with y4, okay, the last value, then plus u delta y3, okay, it keeps on reducing, then u into u plus 1 divided by 2 factorial delta square y2, then plus u into u plus 1 u plus 2 divided by 3 factorial into delta 3y1, and then finally u into u plus 1 u plus 2 u plus 3 divided by 4 factorial into delta 4y0. Okay. So now we have to find each of these values. So first we have to find what is this value of u. Okay, so u is equal, in backward interpolation formula, u is equal to x minus xn, that means x4, divided by h. Okay. So x is 45, and then the last argument, the last value of x is 50, and then your interval of differencing will be 10. Okay, so this will be minus 5 by 10, which is equal to minus 0.5. So this will be the value of u. And now to find those other values, you have to find the difference table. You have to construct the difference table. Okay, so you have your x values, you have your y. So you have to find till delta y, delta 2y, delta 2y, delta 3, and delta 4y. So you write down the values of x, 10, 20, 30, 40, 50. And then your values of y are 15, 27, 37, 45, and 50. Okay. So you continue in the same way. You construct in the same way like how you used to construct the difference table. So 27 minus 15 will be 12. Next, 37 minus 27 will be 10. 45 minus 37 will be 8. 50 minus 45 will be 5. Next, 10 minus 12 will be minus 2. 8 minus 10 will be minus 2. And 5 minus 8 will be minus 3. Then minus 2 plus 2 will be 0. Minus 3 plus 2 will be minus 1. And then finally, minus 1 minus 0 will be minus 1. Okay, so this is our difference table. So now here, you have to remember in the Newton's forward formula, you were taking these values from here, right? But then in this case, for backward interpolation, you have to take in the opposite direction. You have to start from the bottom. So this will be your value of y4. Okay, and then this will be your value, delta y3. Then this will be your value of delta 2 y2. This will be your delta 3 y1, and then this will be delta 4 y0. Okay, so we have found all these various values of these differences, and we have found the value of u. So what we are left is to just substitute in the formula. So therefore, your required missing value F45, you just replace in that formula. What is Y4? Y4 is 50. Then what is U? U is minus 0.5 into delta Y3, which is 5. Then plus minus 0.5 into minus 0.5 plus 1 divided by 2 factorial, and delta square y2 is minus 3. Okay, then again you have minus 0.5 minus 0.5 plus 1 minus 0.5 plus 2 divided by 3 factorial. Delta 4y1 is equal to minus 1, and then your last term will be minus 0.5 minus 0.5 plus 1 minus 0.5 plus 2 minus 0.5 plus 3 divided by 4 factorial, and then your delta 4y0 is equal to minus 1. So I have substituted all the corresponding values of those terms, and then when you use your scientific calculators, you will find that the value of this is equal to 47.977. Okay, and this is approximately 48. Hence, the number of students who are securing less than 45 marks are 48. So there are 48 number of students securing less than 45 marks. Okay, so I hope this is clear. And I hope this problem based on Newton's backward interpolation is clear. Now let us move on to a problem where we have to use Lagrange's interpolation formula. Okay, so the problem is to estimate, we have to estimate F4. From the following data, using Lagrange's formula, okay, and the data is given like this. F1 is equal to 8, not 8, sorry. F1 is equal to 2, F3 is equal to 8, and then F7 is equal to 128. Okay, so we have to find F4 from here. So notice here that in this problem, they have not given us the data in the usual manner, so we have to construct that table based on this given data. So these values, what are the values of x here? The values of x from this question are 1, 3, 7. Okay, so the value of x are 1, 3, and 7. Okay, and the corresponding fx values, or y equal fx, they are 2, 8, and 128. Okay, so this is what we are actually given. Okay, from the question we can see that this is the data that we are actually given. And notice here the data that you cannot use the Newton's backward or forward interpolation because the distance between 1 and 3 is different from the distance between 7 and 3. 3 minus 1 is 2. Okay, whereas 7 minus 3 is 6, 5, 4 is 4. So therefore here your interval of differencing h is not equal for all these values of x. So hence you cannot use Newton's backward or Newton's forward interpolation formula. So that's why you have to resort to Lagrange's interpolation formula. So here, since three values of x are given, that means this is x0, 1 is x0, 3 is x1, and 7 is x2. So you have to write Lagrange's formula, which consists of only x0, x1, x2. And then the missing value we have to find for x equal 4. Okay? So you write down Lagrange's interpolation formula. So Lagrange's interpolation formula to find f4 will simply be x minus x1, x minus x1, x minus x2 divided by x0, divided by x0 minus x1, x0 minus x2 into into y0, then plus x minus x0, then you remove x1, you'll have only x2, then in the denominator you'll have x1 minus x0, x1 minus x2 into y1 plus x minus x0, x minus x1, and then in the denominator you have x2 minus x0, x2 minus x1 into y2. Okay, so here you just directly substitute these values. All these values are already available from the question, so you only have to substitute in this formula. So therefore f4 will be equal to what? It will be, since x you have to find for 4, so it will be 4 minus 3, 4 minus 7, 4 minus 3, 4 minus 7 divided by 1 minus 3, x0 is 1, 1 minus 7, and then your y0 is 2, okay, plus 4 minus 1, 4 minus 7, 4 minus 1, 4 minus 7 divided by 3 minus 1, 3 minus 7, and y1 is equal to what? Y1 is equal to 8 plus 4 minus 1, 4 minus 3 divided by 7 minus 1, 7 minus 3 into y2 is equal to 128. So okay, so if you solve this step by step using your scientific calculators, then you will find that this value will be equal to 24.5. So hence you have obtained the answer. Okay, and if you check from the question, f4 lies between f3 and f7. f3 is equal to 8, f7 is equal to 128. So f4 should lie between 8 and 128. So we see that it is correct. 24.5 lies between 8 and 128. Okay, so there are many more problems which are there based on this Newton's backward, Newton's forward, Lagrange's formula. And I've just shown you just how to solve and apply these formulas. I will be sending you some exercises for you to solve by yourself, and then the solutions also are provided. So it is up to you to study, to practice these questions. They are not hard at all. They're very easy. It's just applying the formulas and understanding the question.